Hello, Woodstock students. This is Mr. Brennan with some thoughts about how to use spreadsheets to a greater advantage than just simply making graphs. Okay, I want to show you a couple of examples of what you can do with a spreadsheet, and then let your talent and ability take over from there. I've got some fitness data from our long-term E. coli evolution experiment. Okay, the LTEE. And you see me bouncing around the spreadsheet here, from cell to cell. One thing I will just point out, I'm now highlighted this data point right here, and you can see that the location is H4, that's column H and row 4, and the contents of the cell is just the number 1. Okay, so that's not news, but I just want you to recognize that there's a kind of an address for any given cell. I'm now in F7, and now I'm in G5, and every time I move around in the spreadsheet, I have a new location, and that's identified here. That's probably pretty familiar for you, but it's a good starting point because I'm going to show you how to get the spreadsheet to compute new numbers based on data that you may have imported into a spreadsheet here. Okay. So let's say that we wanted to, I don't know, just add up some numbers. Okay. What if we wanted to just in this cell right here? What if we just wanted to add up the last two columns of data? That doesn't really have a lot of value for us, I know, in this, from this data set, but just say you want to add them together. Here's how you get started. Um, you tell the spreadsheet that you're interested in having it compute something by typing an equal sign first. And notice whatever I type here, you'll see also that shows up in the toolbar up here. Okay, so equals. And now I could write 1 plus 1 if I want to get these two added together, but it's more powerful if I identify the locations. So I'm going to say equals H4 plus I4, and I'm just going to hit enter. And that gives me the sum of those two cells. That of course is equal to 2. And then if you look at the suggested autofill, it's just copying that same formula all the way down. And notice here, well, it says 1.09, 1.07, and 2.15. It looks like that's not quite the right sum, but let me first accept this and then verify. When I pick on this number here, you see the the actual number is 1.0869, and the actual number here is 1.0662. So both these numbers were both rounded up, but when the sum of them is put together, you don't quite get 1.06, you get 2.15, because the real numbers in these two cells are just a little bit smaller than what's indicated. Okay. So anyway, that's just a rounding issue, right? But you can see you've got the sum of, a minus 5 and a minus 6 in each cell here. 1.15 plus 1.25 will give you 2.40. Okay, well, so that's a thing you can do. You can just simply add numbers together. Okay, let me move over here. In fact, I'll scooch over a little bit. Let's say I wanted to, I don't know, raise a number to a power. Okay, again, I'm going to set this, started off by saying equals, and you can see that my equal sign is showing up there. And I've inadvertently highlighted some cells here, so I'm going to just backspace. Okay. So, all right, got an error here. Hang on. Let me clean that up. All right, so equals. Let's say I wanted column H. Let's say I wanted the A5 numbers to be squared. Okay. So again, I'm going to say H4, and that highlights that cell. And I'm going to raise it by using the Shift 6, that little caret that you see there. I'm going to raise it to the second power, and then I'm going to hit equals. And of course, 1 squared is 1, and then I'm going to accept the autofill and show you that as I move from this first cell where it says H4 squared, when I move down, it now says H5 squared, H6 squared, H7 squared, and so on. Okay. Now again, That information may or may not be interesting or valuable, but it is a computational thing you can do with those cells. Okay, so let's do something that might have some meaning here. Okay, let me erase these two. I'm just going to highlight this data. All right, and delete it. All right, so there it is. Let's say I wanted to examine what's going on with A1 on a closer level. Okay, so I'm gonna, no, better yet, A3. All right, I'm gonna copy my generations. All right, I'm gonna just copy this, Control C, and I'm gonna scooch over to column K and paste it there. And then I'm gonna take A3, the A3 data, and do the typical copy and paste. Okay, and scoot over and there. Okay, now that gives me just this one particular colony of bacteria to look at, okay? And this is the fitness level of each, okay? Well, what if we'd like to see how the fitness is changing over time? What if we'd like to, for example, calculate the momentary slope, okay? In fact, what if we want to get sort of the change in these y values? If we were to graph this, this could be our y value. We want to look at the change in these y values versus the change in these x values. We get a generation by generation kind of slope. In fact, I'll call this column the slope. Okay. Now I'm going to need 2 points for the slope, and in the first row, of course, I only have one data point. So I'm going to scooch down to the second row, and I'm going to write equals. And then to get the slope, I want the change in the y value. Well, let's do it. In parentheses, all right, L5 minus L4, okay, and I'll close my parentheses. I want that difference in those y values divided by, okay, now I want the change in the x values. That would be my generations, right? So open up parentheses, K5 minus K4. Oops, didn't type K. There we go. K4. There we go. And then hit close parentheses. And you see I've got L5 minus L4 over K5 minus K4. I hit that, and my slope is quite small. Let me change the type here. So it's maybe, nope. Let me get a few more decimal places here so we can see what's happening. There we go. All right. I'm increasing decimal places so I can see. I'm getting a very, very low slope, right? Kind of 0.000172. Okay. Well, look, I've only had a little bit of a change of fitness from 1 to 1.09, and that's over 500 generations. So it makes sense that this would be a low slope. Let's keep going. All right, I'm going to copy this down a few places, just a couple, okay, and see what happens. Okay, now the numbers there are interesting in and of themselves, but now take a look at what happens to this, what's happening in here as I move down from row to row. Okay, so I'm just going to hit enter again. Okay, now row to row. Look, I've got L6 minus L5 and divided by K6 minus K5. Oops, moved too quickly there. Hang on. Screen kind of jumped over. So notice it now says L6 minus L5 divided by K6 minus K5. And I'll go one more down here. And you see the references keep updating. All right. So that's a clever thing about spreadsheets, is that they know how to update references. Okay, which is great when you're moving, downward. It can be a little tricky when you're moving left to right. I think I'll save that last hint because I'm running on a little long here. I guess I'll pause for the moment and just say that in addition to the computations that you can get the spreadsheet to do by just highlighting cell addresses, there are also quite a few built-in functions, things like averages, things like log functions, the sine function, the cosine function, so forth. There's all kinds of built-in functions into in spreadsheets. Maybe there are only a few that will make sense in this particular exercise, but it's kind of fun to explore those. All right. I hope that this makes sense for you. I hope that it is valuable and that you feel like you can exploit the features of spreadsheets a little bit better. Okay, take care.